Next series we're going to test for convergence is going to be the following series. This is going to be the sum from n equals 1 to infinity of 3 to the n times n squared all over n factorial. Now, big thing that I see when I take a look at this is the existence of the n factorial. The n factorial makes me aware that I definitely want to use the ratio test. So for the ratio test, we are supposed to set up the limit as n goes to infinity of the absolute value of the n plus 1th term over the nth term. So with that in mind, I'm going to take this expression, replace all of my n's with an n plus 1, and that's going to be my new numerator. Oh yeah, this is going to be a big one. So we will have 3 raised to the n plus 1 power times n plus 1 quantity squared over n plus 1 factorial all over the expression by just leaving the n's alone. As we frequently do for the ratio test, because we have a rather large ratio associated with this and a fraction divided by a fraction, I'm going to change it to multiplication by the reciprocal. 1 squared over n plus 1 factorial times. So we'll flip top and bottom for the second fraction. We'll call this n factorial over 3 to the n times n squared. Now the absolute value bars at this point are a little bit superfluous and redundant, much like the statement superfluous and redundant. What I'm going to do is group together in the fractions things that look like they go together. For example, the exponential with a base of 3, those two things should go together. So 3 to the n plus 1 over 3 to the n. The square should go with the square. Boy, that sounds like my dating life. And then the n factorial and the n plus 1 factorial should go together as well. Now, all of these can be manipulated algebraically. I'm going to attempt to do so. For the first fraction, when you have the same base being raised to an exponent, you can subtract the exponents. We'll be left with 3 to the first power. For the second guy, I'm going to factor out the square and distribute the n to the two terms that are inside. So n over n and 1 over n. And finally, I'm going to expand the factorial that is larger by one single term. So n plus 1 factorial is the same as n plus 1 times n factorial. What we'll be left with is the following. 3 times 1 plus 1 over n, quantity squared, times 1 over n plus 1. Now if I allow n to go to infinity, this will go to 0, and this term will go to 0 as well, telling us that we're left with 3 times 1 times 0. This is equal to 0. Now according to the ratio test, as long as this number is not equal to 1, we can draw a conclusion about this. The conclusion that we can draw, therefore, by the ratio test, the series sum from n equals 1 to infinity of 3 to the n times n squared over n factorial converges absolutely. We'll try and stay nice and consistent with how we put that all together.